Hello friends, welcome to my YouTube channel. So today the problem that we are going to look at is parallel courses 3. So here you are given an integer n which indicates that there are n courses labeled from 1 to n. So we can take it from kind of 0 to n minus 1, but yeah, let's see how the problem goes. So you are also given a 2D integer array relations wherein relations j is say previous I, next I mean, kind of previous course J, next course J, sorry, denotes that course previous J has to be completed before course next course J. Okay, so you are also given a zero indexed integer array time where time I denotes how many months it take to complete the I plus 1 course. Okay, got it. Now you must find the minimum number of months needed to complete all the courses. You may start taking a course at any time if the prerequisites are met. Any number of courses can be taken at the same time. Return the minimum number of months needed to complete all the courses. And also it is mentioned that the graph is, so uh, I'll come to that why it is mentioned the graph is a directed acyclic graph. Okay. Now, sorry, let's look at the problem statement once. So there are three things that the question says are given. Okay, there are n courses first. Okay, there are n courses. Okay, and there is a relations array. It's a two-dimensional array. I mean, it is having multiple pairs. Okay, let's talk about that. Another is, say, time array, which contains, I mean, how much time that particular course will be completed. Okay, and the time is in months, let's say. Now, let's say, for example, take two courses, say 0 and 1. Okay, now if we get 0 comma 1, that means 0 should be completed before 1. I mean 1 can only start if 0 is completed. So that means if we represent it that way, I mean if we have two nodes, say 0 and 1, and there is an edge between them which is pointing from 0 to 1, that means 0 should be completed before 1. Okay, now if we get 1 comma 2, that means 1 will be completed before 2. So there is another node 2. So that's how it will be. Okay, now there's a time array also given. So time array says, so at time array is having, for example, 2 3 4. That means this can be completed in 2 months, this can be completed in 3 months, this can be completed in 4 months. The total time in completing these courses will be 2 plus 3 plus 4, that is 9, right? So that's a simple uh, example. Okay, another example that we can take is, for example, you have 0 1 2, these are the three courses, and say 3 can only start if 0 1 2 are completed, right? Now 4 can only start when 3 is completed, and maybe there's a 6. Okay, and here is 1 5. Okay, so this is how, I mean, the representation is. So that means if you like, this is the graph that I've drawn basically, and as I told you, right, I mean 0 to 3, this edge means that 0 should be completed before 3 starts, 1 should be completed before 3 starts, 2 should be completed before 3 starts. So these are the relations that you are getting basically. If you talk about the problem statement, you're getting these relations kind of. I mean, you'll get 1, 2, 3, 4, 5, 6 edges kind of. That is 0, comma 3. Okay. Then 1, comma 3. Then 2, comma 3. Okay. Then 5, comma 4. Then 3, comma 6. Then 3, comma 4. Okay. These 6 edges you are getting in a relations array. This is relations, sorry, relations. Okay, it's a 2D array. Now if you take n, so n value will be, the value of n will be, there are the number of courses will be kind of 7, because there are 7 courses, right? 0, 1, 2, 3, 4, 5, 6, 7. Sorry, 5, 6. So there are 7 courses. Okay, now there is a time array. Okay, time array. And oh, pardon me. So one thing to be note down is, so these numbers, basically course numbers, are from starting from 1 to 7. So I mean, wrote it like from 0 to 6, as I need to, like, it's kind of off by 1. So since time array supports it from I plus 1, if you note down the statement, right? If you see the statement here, so the time I denotes how many months it will take to complete I plus 1. So that means if it's a fifth course, so it is at time of fourth index, right? Fifth course is at fourth index. So that means I've already, I mean, taken them off by 1. So I mean, I'll start it by, from 0 itself. Like whatever the value of n will be, so I'll start it from kind of minus 1, say. Okay. So now time will be kind of, for example, time array is 1, 5, 2, 3, 4, 6, 8. Okay, that means there are n courses, right? One, so there are, so first course will be completed in 1 month. So if I just wrote the time, it's completed in 1 month. This will complete in 5 months. This will complete it in 2 months. This will complete in 4 months. This will be completed in 6 months. This will be completed in 8 months. And okay, 4, 3, 7. Ideally, it should be 1, 5, 2, 3. 1, 5, 2, 3. Where is 3? Okay. Okay. Sorry. So that's 3. Then 4, 6, 8. 4. Okay, this is 4. This is 6. This is 8. Okay. So these are their completion times. If you see the completion time, so this is the completion time basically. This is 4. Now we need to tell that how much minimum time it will take to complete all those courses. Okay, and we can start these in parallel as well. Okay, for example, now look at these courses, say 0, 1, 2 and 5, right? They can start independently, correct? They don't need any other courses to be completed first, because they don't have any incoming edges. If you note, 0, 1, 2, 6, they don't have any incoming edges towards them. So that is the reason why they can be completed before any other tasks can be completed. They are independent kind of, right? So I mean, if I complete this first, or maybe let's think independently. For example, this task 3, right? If it has to be completed, so before this 3 task number, 0, 1, 2 should be completed, right? So if I start them in parallel, so if I start 1, 5 and 2 in parallel, so maximum time it will take will be the maximum of all, right? So that will be 5. In 5 months, all 0, 1, 2 will be completed, right? So, and how much time 3 will take to complete? So 5 plus 3, that is 8, right? That's how you can think. Let me So another way to think is kind of if I take one by one, for example, if I take note down first of all. So um, there are, okay, now let's see what all things I'm maintaining kind of. So I'll have first of all this graph that I have created, right? So if you see, the graph will be kind of map of integer comma list of integer. So the key will be this integer. Integer is kind of 0, 1, 2, 3, 4, 5, 6. Correct? So this node number is the integer, and like it's the output, like this is the outer edges. So it's the neighbors of this 0 are 3 only, correct? So it will be 0 comma list of nodes which only contains 3. Kind of if a point 1 comma, so that will be again 3. Now 2 comma, that will be again 3. Now if I'll say 3 comma, that will be again 6 and 4, right? If I'll say 4 comma, that will be empty. Okay, then if I'll say 5 comma, that will be 4, right? So that's how, I mean, the if I'll say 6 comma, that is again empty. That's how the graph will be created, right? So this is kind of a graph I'm representing in this structure. Now this is a directed graph, correct? Another is, now that is the reason why I told you, right? That is the reason why they have mentioned the graph is directed acyclic graph. Because if there is a cycle, so you can't predict, right? That, okay, for example, A depends on B, B depends on C, C depends on again A, right? So you can't complete them because that's a cyclic dependency between them. So there is no cyclic dependency basically in this graph. Another is I'll maintain, or I'll take a in degree array. In degree is basically how many incoming edges a node has. For example, this has an in degree of 3. I mean, in degree denotes like how many courses needs to be completed before this course can start, right? So I mean 3 courses has to be completed first before this course starts, correct? That is 0, 1 and 2, correct? Similarly for 4, I need to complete 2 courses, this and this. That is why the in degree of this 4 is 2. So in degree also I can have an array wherein like at particular index I can have the, so index will denote the node ID and the value at that index will denote the in degree. So at index 3 I can have 3, right? In on index 4 I can have 2. On index 6 I can have 1. On index 5 I can have 0. On index 0 I can have 0. On index 1 I can have 0. On index 2 I can have 0. On index 3 I can have 3. I hope that is clear, right? So while traversing the relations, I can maintain this map, okay, as well as this in degree array, right? So if I traverse 0 comma 3, right, I can add this into 0 3, and also I can increase the in degree of 3. In the starting the in degree will be 0, and as soon as like I traverse these relation I can maintain this in degree thing, and also I can maintain this map as well. Okay, now let's think how we need to uh, approach or maybe calculate the maximum or maybe minimum time to complete all these courses. Okay, so if you talk, only think about say this part, right? Maybe let's think about this part only. This part, if you want to complete only 3, okay, so we have 3 edges that are coming towards 3, that is 0, 1 and 2. So 0 can be completed in 1 month, 1 can be completed in 5 months, 2 can be completed in 2 months. So it will be kind of, so if I need to complete 0 and 3, so how much time will take? 3 plus 1, that is 4, correct? Similarly, if I need to complete 1 and 3, how much time will take? It is 8. If I complete 2 and this thing, how much time will take? 2 plus 5, that is this 5, right? 2 plus 3, that is 5. So maximum time it will take is 8, right? So that's how, I mean, if I need to complete only this part, it will take 8 months, correct? Because anyways, this is one way of thinking, 8. Another way could be like maximum of these, that is 5 plus 3, that is 8. Okay. Another way could be kind of 3 plus 1, that is 4, then 5 plus 3, that is 8, then 2 plus 3. I'm considering how many months basically. 3 is the months, not the index basically. So 2 plus 3 is 5. So maximum is 8. Another is kind of maximum of these, that is 5 plus 3, that is 8. Okay. Anyways, I mean, you can think of it. But since we are, I mean, taking it node by node, it's better to think it this way because we need to maintain this maximum value somewhere. Okay. In case of kind of nodes which has in degree as 0, like for this node, this node, this node, and this node, we can directly say the maximum time to complete these ones is 1, 5, 2, and 6, right? Respectively. I mean, and now, okay, if you've heard about Kahn's algorithm, basically it looks similar to that. So, I mean, where we are kind of first of all picking up the tasks which are independent, whose in degree is 0. Now we start completing those. As soon as we complete one, we know, right? As soon as we remove this, or I mean do this, so this can only be done in kind of 1 plus 3 4. Okay, the combination like could be done in 4, correct? As soon as you remove 3, the this thing could be completed 5 plus 3 8. 8 is more than 4, right? So we can update 8 somewhere. So for this, for every node we also need to maintain some max time array. Okay, this will be for each node and we need to update it, I mean, as soon as we find another number which is more than the previous value for a particular node. Okay, so it's a max time for each node or max time for each course kind of. Okay, and our answer could be kind of traversing the whole max time array and find the maximum number, I mean, in the last. Hope, I mean, the explanation is clear to you. But let's see, while writing the code, I mean, it will be more clearer basically. Let's see. Let's try writing the code. Okay. Now, see. For example, we are kind of traversing the relations, right? Okay. When we are traversing the relations, we are saying its previous, relation 0 is previous. Okay. Then we have kind of next, that is relation 1. Okay. And since we are taking off by 1, so we'll reduce. So since the relations or maybe the nodes are given from say there are 7 nodes, so the numbers are 1 2 3 4 5 6 7, but we are considering it from 0 to 6. Okay, since time array is also giving us the values according to kind of index minus 1. Okay, so and also I'm preparing a graph. Okay, integer comma list of integer. Okay, map is equal to, sorry, okay. Now I can say map dot get previous dot add next. Okay, if map dot contains key, I mean, if I already have the previous key, if it doesn't contain any key, so map dot put previous comma new array list. Okay, it's a blank array list kind of, yeah. And just I need to, if that doesn't contain anything, so I'll put it a blank array, and I'll say map dot get previous and then add next to it. If there is already a key, so it will not get executed, and yeah, it'll create this for you. Okay, so this is how we are creating this this map basically, right? Now this map is created. Now I also need to prepare an in degree array. Okay, so this is called in degree, and in degree will be kind of size n. Okay, let's say in degree. Okay, now when I'm traversing this, so I'm increasing the in degree of next plus plus equal to 1, right? So okay, so I hope this is clear, right? This is in degree basically. So kind of in degree of 3 will be 1 2 3. So as soon as I get 0 3, I'll update the in degree of 3. I'll get 3 6, I'll update the in degree of 6. So every time the next node will have like the updated in degree, right, in the relation. So I hope that is clear, right? Now that is okay. I've prepared both these collections. Now I need to prepare a max kind of time, and max time is will also be an array. Okay, now this is the max time that I have taken. Now I'll see how many nodes have the in degree 0 now. I'll traverse this whole array. Okay, int I equal to 0, I is less than, say, your in degree dot length I plus plus. Okay, right. Now I'll say if I'll take a queue first. Okay, this is similar to Khan's algorithm. So I just traverse independent tasks first, and then I will get another independent when those independent tasks are done. So if the independent tasks are done, they will generate another independent. They will generate another independent kind of till the time I'll get like kind of other tasks. So that's how it will be. Okay. Now if my in degree of I is equal 0, that means I'll say q dot add, right? I'll say I. I'll add all those nodes in the queue. Okay. And also I'll update like max time for those. So max time for that I would be time I, right? Okay. Now while q dot is empty, till the time the queue is not empty, I'll keep on traversing, and I'll say q dot poll. I'll say, so this is the course that I'll say independent course, right? Independent course. Okay. Now I'll pick up the first independent course from this queue. Now I'll say what are the neighbors to this course, right? So map dot get independent course. Okay. So I can only do this if map dot contains key independent course. Okay. Now I'll go to the neighbors. So for example, I'm at 3, right? So I'll go to the neighbors like 6 and 4, right? Or for example, I'm at 0, I'll go to 3. Okay. So as soon as I get the list of, so this will give me the list, right? And for example, if I ask for 3, so it'll give me list of 6 and 4. So first of all, I'll get 6. Now this neighbor, I will first of all decrease the in degree of this neighbor, right? In degree of neighbor will be decreased, right? Here also I can use plus plus, right? Yeah, and in degree will be reduced. Also now I need to update the max time, right? Max time for this uh, particular neighbor will be kind of time of that particular neighbor plus max time of the independent course. This will be kind of the maximum of, I need to look at what all two I need to compare. Okay, so basically let's see. So for example, this is the neighbor, right? So I need to compare this plus this with the max of this. Max of neighbor plus max of independent course plus time of neighbor. Yeah, so this is important, right? This you need to see. This is kind of math dot max of time of neighbor. Okay, time of neighbor will be, for example, we are at this node, so neighbor will be 3. Okay, time of neighbor will be 3, so we need to compare 3 plus 1, right? So yeah, this is maximum time of independent. So if you see you are at 6, so maximum time will be this is maximum time, and this is neighbor's time. So we'll add this, and every time we need to add this with neighbor time and compare with the max neighbor. So if that is max, we'll update it to max of neighbor. Okay, that's how this will be, and in degree will be reduced. Okay, and if in degree of neighbor is equal 0, then we say q dot add neighbor. Okay, I hope this is clear. Now we have kind of this max time, and we need to take the maximum of this max time, so that will be our answer, correct? So I hope that is clear. So maximum of this 0 will be 1, 5, 2. For 3 it will be like kind of 5 plus 3 8. Okay, similarly, I mean for this it will be kind of 8 plus 8, that is 16. So that's how. So if we are doing it in parallel, so we should have the maximum answer. So for every node, we know the answer is in max time array, right? So we need to take the maximum of that max time. So uh, we say result, and we just go through this max time array. For example, time, it's a time array, right? Let's say, let's call it k, and yeah, this is max time, right? So I mean result is equal to math dot max result comma k, right? And that's how you can return the result, correct? So I hope this should work. So let's take it one by one. First of all, we have prepared this integer and list of integer map. This is nothing but kind of graph preparation. There we are preparing this graph. Okay. Now we have this in degree, which is saying that, okay, what are the incoming edges for this particular node? I mean, how many tasks needs to be completed before I start this task? Okay, that's how. And then we have the max time, which is denoting for each node how much time will take to complete this course. Okay, now traversing the relations and preparing this map in the in degree array. Now we have a queue wherein we are only putting those which are independent, for which the in degree is 0. And also we have more in degree tasks whose in degree is 0, and we are putting them in queue as soon as we get them. Okay, since as soon as we are completing the tasks, independent tasks, we have more independent tasks available added to the queue. Now pull them up. If that is there in the, we'll go to the neighbors, we'll update the max time. So this condition you can go through again. Then in degree of neighbor will be reduced. Then if it is 0, then putting into the queue again, and then take the max of the max time. That is our result. Now let's copy this and paste it there. Let's run it. Okay, let's submit it. Yeah, so submit. Hope you like this video, and yeah, feel free to share it with some of your friends, and do your comments in the comment section to let me know that, I mean, what all things we can do here to improve the videos. Okay, thanks a lot.